About 5 or 6 years ago, I was at a conference and somebody put this statement up on the screen. I wish I could remember who it was so I could credit them properly, but unfortunately, I didn't think of this for myself. But we all looked at it and nodded and said, yes, obviously. Of course, it works like this. Unfortunately, it's been so obvious that it's taken a good 5 years before I've started to have conversations with people which embody the concept here. I help people with their performance issues. People come to me and say, how do we get our system to go faster? And some of them are now starting to say, how do we spend less money on the cloud? In the good old days, where we had on-premises kit, you went out, you bought new hardware, you procured it, you went through a sizing exercise where you basically guessed how much you would need and how much you would need throughout the life of the hardware, which was typically 3 to 5 years, and you'd sort of allow a bit of margin for growth and change in the business, and then you decide what you're actually willing to spend, and you'd go out and you'd buy it. And then, of course, you were stuck with it. You had to make it last for that 5 years. And similarly, you would have a discussion where you say, well, how many CPUs do I want to license with Oracle? Because that also had a cost. And then once you'd bought the hardware, you were also stuck with that for 5 years. And that was a capital purchase, and you depreciated it over 5 years. And at the end of 5 years or so, longer if you were luckier, you basically started again. Of course, in the meantime, things change. People would say, it doesn't perform well enough. This is not meeting our requirements. And so someone like me would come in and look at it and decide what to do about it. I learned very quickly that there was very little point saying to a client, look, you really do need more resource, you need more hardware. You've got too much on this box. Because nearly always the answer would be, well, look, I'm sorry, we've spent all of our money on this hardware. We haven't got any more. We're not going to get any more. So we have to do the best with what we can. And that's how I've made my living for years. The cloud changes this a bit. Whereas on-premises was a capital expenditure, and then you depreciated it over time, in some ways, the cloud is an operational expense. It's a form of rental model. You rent the hardware rather than purchase it. You might bring your own existing Oracle license with you, in which case you're licensed for exactly what you were licensed for before. Or you might have a cloud subscription that includes your Oracle license. And if you start to design the cloud you want, every decision you make, every architectural decision has a cost consequence. You know, how many CPUs do you want? What shape of server on the cloud are you going to use? What kind of storage do you want? How much volume? What level of performance do you want from it? And every cloud has a configurator tool. Oracle produced this configuration tool, and you put in what you think you want, and it tells you how much it's going to cost per month. It's like any product configurator on a retail site, which is exactly what it is. And as you adjust the settings in here, you can see precisely what it's going to cost you. And here's an example screenshot. It's immediately obvious that CPU is the dominant cost. Yes, the storage has an impact, but it's small compared to the CPU. Very quickly, you ask yourself, well, how much cloud do I want? How much? And then you have to say, well, how much performance do you want? Well, you can have as much performance as you're willing to pay for. So the question becomes, how much do you need? Or even, what do you mean by performance? That's possibly the first question. My favorite book on Oracle performance tuning is probably Carey Millsap's Optimizing Oracle Performance. That book is now 20 years old. And it was probably one of the earliest Oracle performance books that started to say, focus on response time. Time is everything. And Carrie introduced me to another book, which is probably my favorite general book on performance. This book is now 40 years old. It's not about tuning computer systems at all. It's the story of a man who has a factory and he has to make it profitable again. And Goldratt himself, who was a physicist rather than a business specialist, came out with the idea that constraints are everything. He talks about constraints or bottlenecks. And a bottleneck is anything in a process that you spend time waiting for. And in a factory, you can see where the bottlenecks are because there's a big pile of inventory sat in front of it waiting to go into the process. And that inventory costs money. It represents money tied up in the business. This is true of manufacturing. It's also true of IT and of computers, where the inventory is data waiting to go into a process and come out the other side. So Goldratt proposed a 5-step process where he says, first of all, you identify the constraints in the system. What are your bottlenecks that are delaying you? And then you work out how to exploit them, how to get the absolute most out of the constraints that are there, and how to divert the resource that you need to them. And everything else is subordinated to that. The things which are the constraints take precedence over the things which are not the constraints. And then when you've done that, you look at how to provide more resource to the constraint. And you go around that loop and you iterate until you achieve the performance that you need to achieve, however you define that. And as you do that, you tend to find that you chase the bottlenecks around the system. And that's normally a sign that you're making progress. So what is the goal? Well, in the book, the goal was to increase the throughput of the factory so that it produced more saleable product, while simultaneously reducing inventory, money tied up inside the business on stuff, and simultaneously reduce the operating expense of the factory, which is things like staff, energy, simply renting the site. Well, change a few of the words and you can say exactly the same thing about a computer system. In the cloud, the goal is to increase the throughput of the system, the rate at which it produces the information you need, while simultaneously reducing the response time and the cost of the resources. Now, that's certainly true in the cloud. It's also true on premises and even on a virtualized on-premises system and an old-fashioned on-premises system, but the feedback loop is longer there. So the first question is, how much performance do you need? There's certainly no point having the system deliver more performance than the business needs. There's no point delivering a report at 2 a.m. in the morning to a user who is tucked up in bed until 6. Let me tell you a story. This is a real life example of, it happens to be a PeopleSoft financial system. It doesn't matter that it's PeopleSoft. It doesn't really matter that it's financials. It just happens to be a good example. This customer is an insurance company. That's not particularly significant, except that insurance companies love to slice and dice their data far more than retail companies. So they have a very heavy overnight GL, general ledger reporting batch. And they run this every night. And it's a real treadmill to be on. And they moved from Supercluster, which is the old Solaris form of Exadata, to Exadata Cloud-at-Customer. Physically, it's still in their machine room, but it's administered and paid for as if it was in the cloud. And how you pay for it is actually what matters. They didn't bring their own Oracle license. They took the license that came with Cloud-at-Customer. And for that, over their minimum contracted amount, they pay $1.34 per OCPU per instance per hour. Now, I $1.34 an hour doesn't sound like much until you add it up and you realize it's $1,000 per OCPU per month. And if you start to talk about the number like that, actually pretty soon management realize that this is a significant chunk of money. You can start to have a conversation saying, yes, we can add a CPU. It's going to cost you $24,000 a year. And that starts to be a number that they can see on their budgeting spreadsheet. So when they first commissioned this system, they went into a sizing exercise with Oracle's assistants, and they came out with, we need 6 OCPUs across 2 instances each during the day, and we need 10 OCPUs per instance at night, assuming a 2-node rack instance. Probably the most useful and significant thing this customer did was they defined a quantitative definition of acceptable performance. And it was this, it was the reports need to be available to users by the start of the working day in continental Europe. These guys are based in the east coast of the US, and they've got sites around the world, quite a big European footprint. And we had to do this without making the system unavailable to the Asia Pac users, because their working day corresponds to the US overnight. At night in the US, all the reports that aren't needed till the start of the US working day in the US, they can wait. They aren't needed till 6 in the morning, so they're less important. That became the definition of our goal. Now, recently, we developed a way to prioritize some of these reports. We'd been struggling with this long tail of processing, so we said, right, let's make the long-running processes start first so that they have a chance to finish earlier, and then we'll fill up the gaps with the shorter processes. And then the business came back to us and said, look, if you prioritize the international global reports, which are needed in Europe and Asia Pac, over the North American reports, you can get them done earlier. And the North America reports, they can wait. So we ended up with a new SLA that the international reports have to finish by 2 a.m. Eastern, which is 4 p.m. in Singapore. And the North American reports, well, we don't need them till 6 a.m. This is an example of what Goldratt calls elevating the constraint. What we've done is we've taken out non-essential work from a constraint so that the essential work gets through faster. And then we can address the lower priority North American reports, and we have plenty of time to do that. So sometimes you have to refine your definition and your goals and be very clear. Now the question becomes, how many CPUs do I need in order to consistently achieve my defined performance target? So we did a few initial bits of tuning. When we moved from supercluster to Exadata, we had fewer CPUs. Instead of 80 relatively slow CPUs, we have the modern, very fast CPUs, but we have relatively fewer of them. So immediately we reduced the concurrency of our processing. So we got less contention between the processes because of that. We'd already been using the free base level in memory. That alone enabled us to reduce the 10 CPUs down to 7. If we hadn't been using in memory, we would have been up on 10. So there's an example of bringing a free Oracle feature to bear, which reduced our CPU and reduced our cloud costs. Since we've been on Exadata Cloud-at-Customer, we are fully licensed for pretty much everything, including in memory. So then we've used far more memory allocated to the in-memory store, and we were then able to reduce the CPU again. That got us down then to 6 CPUs. We've done things like SQL profiles. We disabled parallelism. Now, in-memory really only works with parallel query. But of course, parallel query is quite a brutal way of using CPU, and CPU is the thing that costs. But because this is engineered system, we can duplicate the in-memory to be the same on every node. We were able to save CPU by disabling parallelism and still use the in-memory. And then we did a little more application tuning, and we implemented the resource manager, and we were able to reduce to 5 OCPUs. And that's where we are today. And we've got plans to push it down even further. And every time we turn off a CPU, we're saving $24,000 a year. So what has happened is, as they have consumed their Cloud-at-Customer CPUs, they've crossed the limit of their minimum contracted number of CPUs, and they get a monthly invoice for their extra CPUs. So they've started to really care about this. So you can see how in the cloud, because you pay for CPU, you are incentivized to minimize your CPU utilization. And I think this is going to be a trend. I really believe that we're going to see more and more clouded systems spending more and more of their time at or close to 0% free CPU, which raises a question. What do you want to happen when you run out of CPU? So certainly in the cloud, if your system is not constrained by CPU, at least some of the time, you have bought too much. So what happens when you do run out of CPU? Maybe the better question is, what do you want to happen when you run out of CPU? This is a graph of our system activity. It's basically active session history, and it's a typical day. It runs from 7 in the evening till 2 in the morning. And here's the big NVision GL batch. Let's change the y-axis. Let's set it to 24 because we have 24 virtual CPUs, because we have 2 nodes of 6 OCPUs each at this time. So this is the 12 OCPUs that we're paying for. Here's the colored areas. That's what we're using. The white areas, we're not using them, but we're paying for them. We're licensing the CPUs with Oracle, and we're paying for them at $1,000 per CPU per month. If I showed you the complete typical 24-hour working day, it's even worse. The proportion of white is much larger. What can I do to reduce the amount of CPU that I'm using? What is the consequence of doing that? If I reduce the CPU, I'm going to push that spike of processing down. It's going to get wider. We did this test in our performance test system. We reduced it from 6 to 4 CPUs. The blue area is our reporting. This lighter colored area are 2 other higher priority processes. Roughly speaking, the volume of colored area on both charts is the same. When we push the number of CPUs down from 6 to 4, the duration of the batch compensated by getting longer. So how many CPUs do I need? How far can I push it down while the growth of the runtime of the process is within my service level agreement to deliver the reports in time? And this brings me to Resource Manager. Without the Resource Manager, all processes on the database are pretty much created even. They have to fight it out to get onto the operating system run queue. And there's a good chance that a process may go to sleep while holding a database lock, or worse still, a latch. And normally you get significant contention problems when that happens. But if you ask the users who needs what by when, what is most important to you and what is the next most important thing, and so on, you build up a hierarchy of what is necessary. And you can reflect that hierarchy in a resource manager plan. And it's quite possible that you'll get different answers at different times. Maybe during month end, the requirements are different to the rest of the month on a finance system. Maybe not. So you can maybe even have to have different resource plans which are applicable at different times, and you can manage that too with scheduler windows. Now, the resource manager has been in the database for a very long time, but it's surprisingly rarely used. But with the resource manager, I think you can, in many systems, you can meet your objectives and simultaneously use fewer resources, particularly CPU. One of the other benefits is it gives you visibility of when the resource manager has intervened and when you have run out of CPU. Because instead of a session still being reporting as on CPU so that the event is null, you get a new event, resource manager CPU quantum. And that's what happens when the resource manager detects that you've run out of CPU and someone is waiting trying to get on CPU. It reports differently. So you create your resource plan to reflect the hierarchy of processing. Very simply, if a business is waiting for the output of a process, then that's a high or higher priority process, and it needs to be guaranteed a higher proportion of the available CPU. And if a process is finishing before the business needs it, well, then they're not waiting, and it is a lower priority process, and it can afford to be pushed off the CPU, even at the consequence that it takes longer to run. An example. In the GL overnight batch, there are a set of reporting tables that are generated, and they are not needed until the start of the US working day because they're only used by people in the US. So there's two things we've done. We're going to push their start time back so that it comes after the typical finish time of the Envision report when there's plenty of system available. And we've put them in a lower priority consumer group so that if there is a shortage of CPU, they are restricted, and we've restricted their degree of parallelism with the resource plan too. So just in case the overnight reporting window runs late, it can't make it run even later by running into these processes. So we've protected the highest priority processes in the system. And most nights, as long as nothing goes wrong, we can meet our objectives. There's a flow of processing in your typical financial system. You post transactions through AP and AR. They get posted to the ledger. We generate summary ledgers in this particular system. We generate materialized views on the summary ledgers because that gets some Exadata features in. We use it to get hybrid columnar compression in. And then we run the reports off the summary ledgers, which get rewritten to the materialized views. So the process that generate the summary ledgers are on the critical path to the reports. And then we have some other processes which are less important. There's extract to S-based reporting cubes. We've got ad hoc user query going on, and we've got some ad hoc reporting goes on. And there's some other processing that's only consumed in the US, so it has a later deadline. So we started to build a resource plan. And I'm going to show you the progression of this resource plan. The whole thing probably took about 3 years to develop from end to end, from what you're going to see over the next few slides. So default resource plan has to have a sys group, which is the highest priority group. That's for the DBA operations. And then there's an others group at the bottom. There are 8 potential levels of priority in a resource plan. And within a priority level, you can have different consumer groups, which can be given different guaranteed amounts of CPU. We created a PeopleSoft group, highest user group. It's the application. Anything that's a PeopleSoft process, it's the highest priority other than sys. But things like the summary ledger generation and the Envision reports, they're slightly lower than the PeopleSoft group because we need PeopleSoft to be the online application and all the other things that take precedence. It's those Asia Pac users who need the system to work. Summary ledger group is higher priority than Envision because it's a prerequisite. You have to generate the summary ledgers before you report. So you don't want to slow that down because it will slow down the report delivery later. We then have our ad hoc query. And then we have some other lower processes like that Essbase extract. It's not at the very bottom of the list, but it's quite way down. We also disabled parallel query for the Essbase group, so it couldn't take too much CPU, and it didn't particularly affect it. That's probably where we were with our initial resource plan. That was probably the first thing we went into production with. And then over the years, other things have been added as they've been identified as a requirement. We created a high and low group. So a low group was pretty much anything else. We've got people working in SQL Plus and SQL Developer, would you believe it, writing ad hoc queries. And we have a special weekend process for statistics management for 2 very large tables, and that gets very high priority and high parallelism. We've got another reporting table generation process, lower priority than Envision, but higher than the queries. We decided to put a runtime limit on some of the SQL Developer stuff. So if someone wrote a very poor query that would run for hours, the resource manager would intervene and say, no, this is going to run for too long, or has run for too long. We've pulled out some of the longer running Envision processes and made sure they get more CPU and in preference to the other Envision reports. Again, this is just about getting the long runners to finish faster, because so you're not waiting for them at the end of the batch. Ad hoc Envisions are treated in very much the same way as ad hoc queries. They're basically the same thing in a way to the business. And then most recently, we split out the ad hoc queries in online ad hoc queries versus scheduled ad hoc queries so that we could put a time limit on the scheduled ad hoc queries. The online queries can be time limited in the application. And that's pretty much where we are today. And that is an evolution over a number of years as the requirements emerged and developed. And then because we're on a cloud system, we might change the number of CPUs. So I've created a resource plan for each number of CPUs. So you might have 4, 5, or 6 OCPUs per instance. That's 8, 10, or 12 virtual CPUs. The only real difference is different parallel query limits. So we restrict the parallelism more severely as we reduce the number of CPUs. And then when we change the number of CPUs, we just have to change a few parameters. The resource plan is defined by the resource manager plan parameter, and when we change the number of CPUs, we change the plan. And there are a few other parameters we change in line with them because we wish to restrict some of the parallelism and the job queue processes more severely than would be done by default. So we change these 4 parameters as a set when we change the number of CPUs, which you can do dynamically on Cloud-at-Customer. So that's our resource plan. We now have to map sessions to those consumer groups in the resource plan. You can define mapping rules in Oracle to map various session attributes to specific consumer groups. And they have these 11 rules, and explicit is always at the top of the hierarchy. You can't move that. The attributes that you can map the resource manager by include module and action. And this is another reason why application instrumentation is so important. So ever since Oracle 7.3, they've delivered a PL SQL procedure called DBMS application info, which lets you set the module and action for a session. And from there, it's picked up by AWR and Ash, and you can see it in the Enterprise Manager. You can also turn trace on and off with it. You can set like a watch point in a debugger, and it will trace a particular module and action. It's also capable of being used to drive the resource manager. And you can create mappings that map particular values of module or module and action to particular mappings, either by equality, or you can use a like string, or you can use a regular expression. So in PeopleSoft, there is some delivered instrumentation, as you go through the online application, the component and page is written to the module in action. We've also added our own instrumentation using triggers and a fine-grained audit handler for Envision, so that we can identify the name of the process being run and the Envision report within a report book. In general, module is the process name for batch. We've changed the hierarchy of the mapping because of the nature of our instrumentation. We're not using service and client, we're only using module and action and client program name and Oracle user. And the hierarchy here is that the specific overrides the generic. So everyone logs in as PeopleSoft, that's pretty generic. But then there are various programs within that, and the various programs set various modules and actions. As you go up that list, they become more specific. If multiple mapping rules match a current session setting, Oracle applies the highest priority in this hierarchy. So how did we build that mapping in? If you logged in as sysadmin or SBase, you are either a sysadmin group or an SBase group. We also mapped Oracle function in memory to the SUML group because we put the summary ledgers into in-memory. And there's a couple of places where we do explicitly set the resource consumer group in code, normally in a trigger. We then mapped certain modules to certain consumer groups. So report book is the Envision multi-report report book. You can see SQL Developer down there goes to the low limited group. Some reports where we could identify the names, this USGL reports you can see here, we pattern match the combination of module and action, and we said these are our long-running reports, we'll put them into that slightly higher priority group. And this built up over time. So what's the effect? This stripe here, that's the background application, and you can see it runs all the time through the night. That's our Asia Pac users again. Highest priority, they don't get squeezed. And then about 9 o'clock, the Envision reports start. There's your summary ledger, there's the Envision report. And this orange stripe, that's ad hoc query. There was a big ad hoc query run this particular night, got started about 11:30 while the Envision was still running. And you can see it got squeezed. It got squeezed by the resource manager allocating CPU to Envision and the online application in preference to CPU, which is a lower priority group. And then as the Envision reports finished and the Envision load tails off, it allowed the query reports to consume more resource. And as the pressure came off, the query reports could take as much as they wanted. There's the summary ledger, and there's the query. If I look at the total activity on the system, these stripes, which are very even, are our queries, our ad hoc queries, and they run and they're active for quite a long time. The little vertical fringes, that's a quirk of the ASH sampling and the way I've graphed it in Excel. And you can see they got going 11:30 to midnight. This is just the time reported as CPU quantum. This is the amount of time that the queries were held up for waiting for Envision. So it was the queries that got pushed off the run queue to allow Envision to make progress. And then this is the amount of time that they were active on CPU actually doing something. So this is the period of time that the queries really were working. And you can see it starts to build up here as the Envision eases off. This is an example of the resource manager doing its job, prioritizing the high priority stuff, and the lower priority stuff has to wait. So when you build your custom resource plan, you have 8 levels of priority, and within each level, you can have several consumer groups with different CPU guarantees, and each of them could have different degrees of parallelism as a restriction. And what I've shown you here is at the end of an evolution. We didn't start with this day one and write it out. It evolved, and we adapted as things changed in the business, and as our understanding of what mattered to the business became better, and as they told us things which they hadn't told us before because they didn't realize we could do anything about them. If you don't have enough information to create a resource plan, at the very least, turn on the Oracle delivered default resource plan, because when you do run out of CPU, at least it will report as Resource Manager CPU Quantum. You will have visibility that you have a CPU bottleneck, and then you can start to have the discussions around what you're going to do about it. Good design, tuning, it's the same in the cloud as on premises. It hasn't changed. The important thing though now is you can measure how much you're spending on the cloud and how much you're saving through doing some performance tuning. And you can choose to spend more or less on the cloud in order to achieve what the business wants. If you want more CPU, you can have it, but at a cost. It's been very interesting to see the change in behavior from people who have come from an on-premises world. And I say people, the people who pay for this stuff, the managers, the program managers who have to care about the budgets. Nothing concentrates the mind like that invoice from Oracle at the end of the month saying, here are your cloud extras. You really can have as much performance as you're willing to pay for, but no one's going to pay for more than you need to achieve your objectives, which means you have to be very clear about what your objectives are and what is most important to you. So I hope that's been useful. I hope maybe you'll look at your system a little differently. We've come to the end. So let's see if we have some questions.